picture this for a second. You have this multi-million-dollar aircraft, and it's currently skimming just above the treetops in these, like, incredibly dense, humid jungles down in Brazil.
Right.
And then, literally hours later, an identical aircraft, same exact model, is out there tracking suspected pirate vessels over the freezing, wind-whipped waters of the Irish Sea.
It's quite the contrast.
It really is. So today, for this deep dive, we are basically skipping all the supersonic stealth jets, the autonomous drones, all that flashy stuff, to look at the unsung hero that's actually making both of those completely different missions possible.
Yeah, and we are looking at a tactical transport aircraft with propellers, of all things.
Right, propellers.
Exactly. And, if we connect this to the bigger picture early on here, the global footprint of this specific machine, it reveals this massive fundamental shift in what the word security even means for governments today.
Yeah, totally. So I spent the week digging through Airbus's official corporate and technical documentation. I'm talking spec sheets, order logs, operational reports.
Heavy reading.
Oh yeah, lots of PDFs. Specifically, I was focusing on their military aircraft division and this platform called the C295. And honestly, in a world that is just obsessed with flashy next-generation technology, there is a profound lesson in adaptability here for all of us.
Absolutely.
Because the documentation paints a picture of a machine that is just doing the unglamorous heavy lifting for the entire world. I mean, it handles everything from military intelligence to, humanitarian disaster relief.
Which is exactly why you, listening to this right now, should find this relevant. I mean, we are constantly sold this idea that innovation means hyper-specialization, right?
Right, like an app that does one tiny thing perfectly.
Exactly, a tool that does one specific thing flawlessly. But the C295 represents the exact opposite philosophy. It basically proves that sometimes the most advanced solution isn't the most delicate or, the most specialized one. It's the one that simply refuses to quit, regardless of the environment or the mission parameters.
Okay, let's unpack this. Because the sheer scale of what this aircraft is doing really requires us to look past those old-school propellers.
It really does.
According to the Airbus documentation, the C295 is classified as a multi-role tactical airlifter, and the adoption rate is serious. Like, they note 329 total orders.
Wow.
Yeah, 241 deliveries, and 238 of these things are currently in operation around the globe.
I mean, a global fleet of that size for a single tactical airframe, that is a massive logistical footprint.
Yeah.
It basically means you have this standardized platform operating across completely different geopolitical and environmental zones.
Well, let me push back a little on this premise, though, because I was looking at its basic specs, right?
Okay.
It can carry up to 8 tons of payload or up to 70 troops, which is great, but it has a maximum cruise speed of just 260 knots.
Yeah, it's not breaking any speed records.
No. I mean, in an era where military budgets are pouring like billions into hypersonic missiles and jets that break the sound barrier without even breaking a sweat, why are global governments and these major non-governmental organizations clamoring for a twin-turbo prop plane that maxes out at 260 knots?
It's a fair question.
I mean, it sounds less like a cutting-edge asset and more like a, dependable, slightly beat-up pickup truck.
The pickup truck analogy is actually perfect, provided we look at what a pickup truck represents logistically.
How so?
Well, what's fascinating here is that its appeal lies entirely in baseline reliability. Like, think about it. When you were running a disaster relief mission after a massive hurricane or resupplying some remote mountain outpost.
You don't want a Ferrari.
Exactly. You do not want a delicate sports car of an airplane that requires a pristine paved 2-mile runway and a team of software engineers just to get the engine started. You want the machine that starts every single time, even if it is completely covered in mud and, thousands of miles from a specialized maintenance hub.
Yeah, and Airbus actually loves to tout the reliability of the engines, specifically in their materials. They point out the C295 is powered by 2 Pratt & Whitney Canada PW 7G turboprop engines.
Yes.
And the documentation claims this engine family has accumulated over 160 million flight hours across 6,000 aircraft globally.
It's a staggering number.
Hold on, though. 160 million hours. Is that actually a meaningful metric for an aircraft buyer, or is Airbus just, throwing massive numbers at us to sound impressive on a corporate spec sheet?
No, it is arguably the most vital metric for a logistics commander.
Really?
Oh, absolutely. 160 million flight hours means the engine's design quirks, its maintenance needs, its failure points. They are completely understood.
Oh, I see.
Yeah, there are no expensive, mysterious surprises waiting for you. And more importantly, it guarantees a global supply chain.
Because there are 6,000 other planes using it.
Precisely. If a water pump fails on an engine in the middle of Chad or Afghanistan, finding a replacement part for an engine family that's used on 6,000 other aircraft is relatively easy.
That makes total sense.
The documentation actually calls this outstanding operational availability. The aircraft isn't sitting in a hangar waiting weeks for some bespoke, custom machined part. It's out on the tarmac, ready to fly.
Okay, so that makes the focus on endurance over speed much clearer. Like, if you are dropping supplies into a flooded region, you don't care about breaking the sound barrier.
Not at all.
You just need the plane to get there, survive the landing, and get back in one piece.
Exactly.
And that actually brings us to the physical engineering, because the Airbus specs really boast about its SCOTOL performance.
Short takeoff and landing.
Right. They specifically note it can operate from unpaved strips, soft dirt, sand, and even grass. Which, how do you slam a multi-ton aircraft loaded with 8 tons of cargo into a muddy field without the landing gear just snapping off or sinking entirely into the earth?
Well, they basically had to completely rethink the landing gear physics. Commercial jets landing gear. That's designed for smooth, hard concrete.
Right.
But the C295 uses this heavy-duty trailing arm suspension system with tandem wheels.
Trailing arm using it drags behind.
Yeah, essentially. So instead of a stiff vertical strut that transfers the shock directly up into the airframe, which would crack it, the trailing arm acts like a massive shock absorber. It swings slightly to soak up the impact of a rutted dirt runway.
Wow.
Furthermore, the tandem wheels use lower pressure tires, which spreads the immense weight of the aircraft over a much larger surface area.
Oh, like snowshoes.
Yes, it is the exact same principle as wearing snowshoes to stop from sinking into deep powder.
Okay, so it has this heavy, ruggedized lower half to survive the mud. But the documentation also states this thing can climb and cruise at altitudes up to 30,000 feet, and it has an endurance of up to 13 hours in the air.
It does.
That seems contradictory to me. Usually an aircraft built with heavy landing gear to smash into dirt runways isn't aerodynamically efficient enough to loiter in the sky for 13 hours.
You're pointing out the core tension in aerospace engineering right there.
Right.
You are constantly fighting the laws of physics.
Right.
High altitude, long endurance aircraft usually have these long, delicate wings to minimize drag like a glider, but they cannot survive rough landings.
Yeah, they'd snap.
Exactly. To achieve both, Airbus implemented a baseline engineering upgrade to the C295, which is wingless.
Oh, the little vertical fins at the very tip of the wing. You see them on commercial flights all the time now.
Yep. Think of a winglet like a dam at the end of a river.
Okay.
As a plane flies, high-pressure air underneath the wing constantly tries to spill over the edge to the low-pressure area on top.
Right, because of the pressure difference.
Exactly. And this spillover creates a chaotic, swirling vortex of air at the wingtip that actually pulls the aircraft backward. It creates drag.
I didn't know that.
Yeah, so the winglet acts as a physical wall, stopping that spillover. It neutralizes the vortex and actually turns that wasted energy into forward lift.
That's brilliant. Airbus claims these winglets improve takeoff characteristics from hot and high airfields, places where the air is thin and engines struggle for lift, and they say it reduces overall fuel burn by 3 to 6%.
Now, 3 to 6% might sound trivial to someone driving a Honda Civic.
Right, like maybe saving a few bucks at the pump.
Exactly. But when you are burning aviation fuel for 13 hours straight, that efficiency translates to massive operational flexibility.
Oh, for sure.
It is the literal difference between having to abandon a search and rescue grid over the ocean because you're low on fuel, or being able to loiter for an extra hour to actually find that missing vessel.
So you pair that aerodynamic trick with an unobstructed 12.69 meter pressurized cabin, which is basically a highly protected flying tube.
Essentially, yes.
And the result is an airframe that is, combat proven in Iraq and Afghanistan, but also operates in the freezing winters of Poland, the high mountains of Colombia, and the extreme heat of the Egyptian deserts.
It's incredibly versatile.
Yeah, operators have racked up over 600,000 flight hours in these environments.
And that 600,000 hours of operator data validates the fundamental system design. The aircraft survives extreme temperature swings, sand ingestion, and these incredibly rough landings without structurally compromising the pressurized cabin.
Okay, so we have established the physical mechanics of how it survives the dirt and stays in the air for half a day. let's look at what it actually does when it reaches its destination.
Let's do it.
Because the Airbus materials detail a highly adaptable set of brains paired with this rugged brawn, and here's where it gets really interesting.
You're talking about the modularity.
Yes, the documentation heavily emphasizes these palletized modular systems.
Right?
Meaning, instead of a country buying a dedicated water bomber, and then a dedicated medical plane, and then a dedicated cargo plane, which would cost a fortune buyers, just get the empty flying tube.
Just the basic airframe.
Right. And depending on what pallets you slide into the back, the aircraft fundamentally changes its identity in a matter of hours.
The logistics of that are honestly ingenious. The cabin floor is equipped with these roller tracks and locking mechanisms.
Okay.
So you simply roll a pre-configured pallet up the rear ramp, lock it into the floor grid, plug the system into the aircraft's power supply, and boom, you have an entirely new capability.
Like plug-and-play Lego sets for a multi-million-dollar aircraft.
Exactly like that.
And the variants listed are wildly different. I mean, you can lock in a water tank and it drops retardant on a forest fire.
Yep.
Swap that out for intensive care beds, and it is suddenly a medevac plane providing emergency medical response.
It's seamless.
Put in different electronic tallets, and it becomes a signals intelligence aircraft, a SIGINT listening in on communications. It even has a removable refueling kit that turns it into a mid-air gas station.
Delivering up to 5,000 kilograms of fuel to other planes and helicopters.
It's crazy. And they also list an armed ISR version, providing close air support with actual munitions.
But you know, this raises a really important point regarding human limitations.
What do you mean?
Well, how does a flight crew safely manage all of those wildly different missions? Think about it. A water bombing run at a few hundred feet over a burning forest requires entirely different situational awareness and sensor data than a signals intelligence mission cruising at 30,000 feet.
Oh, wow. Yeah, that's true.
You cannot expect a pilot to memorize entirely different analog control panels for every single mission type.
Ah, okay. Well, the documentation points to something called FITS for this. FITS, the Fully Integrated Tactical System.
Right. FITS is basically the central nervous system of the C295. It was developed by Airbus Defence and Space, and it acts as a universal translator for all those modular pallets we just talked about.
Okay, so how does it work?
It uses network computers to gather data from the outside world, whether that is radar or EOIR.
Which is electro-optical and infrared cameras, right?
Correct.
Yeah.
Or even AIS, the automatic identification system used to ping and track maritime ships.
Oh, gotcha.
So FITS processes all that raw data and presents it on standardized modular consoles in the back of the plane.
So the operators sitting in the back aren't looking at 50 different confusing raw data feeds.
No, not at all.
FITS synthesizes it into one clear picture of the battlefield, or, the disaster zone.
Exactly.
And this philosophy extends right to the pilots up front, too. The Airbus specs highlight this advanced cockpit built around the Collins Aerospace ProLine Fusion avionics system.
Yes.
And it requires only a two-person crew. It uses 14.1-inch multifunction touchscreens, and it is fully compatible with night vision goggles.
See, the touchscreens are not just cosmetic upgrades so it looks cool. This is entirely about cognitive load management.
Okay, break that down.
In a high-stress environment, like say a medical evacuation under hostile fire or a low-visibility supply drop in a storm, human pilots have a finite amount of mental bandwidth.
Sure, they can only process so much at once.
Right. You want the internal computers handling the raw flight dynamics, the complex navigation routing, and the sensor integration. The 14-inch displays just present synthesized, actionable options to the crew.
Basically, letting humans do what humans are best at, which is making complex, ethical, or strategic judgment calls, while the computer handles the math of, keeping the heavy metal tube in the air.
Perfectly said. Furthermore, the avionics comply with the strictest current and future civilian airspace regulations.
Yeah, I saw that.
The documentation notes systems like ADS-B out, TCAS2 version 7.1, and CPDLC data link communications.
Okay, let me stop you there, because that is just a dense wall of aviation alphabet soup. What do those systems actually do for the pilots on a practical level?
Okay, so TCS2 is essentially an automated collision avoidance system.
Okay.
It actively talks to the transponders of other aircraft in the sky to automatically prevent mid-air crashes.
Oh, that's crucial.
Yeah. And CPDLC, that is a data link that lets pilots send text-based messages directly to air traffic control.
Like texting?
Sort of, yeah. Rather than trying to decipher crackly, static-filled voice radios over really long distances, they just get clear text instructions.
So by having all these strict civilian safety standards baked into a rugged military plane, The C295 can take off from a highly regulated international airport in Europe, fly seamlessly through commercial flight paths, and then land on a contested dirt runway in a conflict zone without ever changing its equipment.
Exactly. And that dual nature capability is the primary driver of their recent sales.
Which is a great pivot, actually. Let's look at the actual global orders from the Airbus newsroom updates, bringing us right up to May 2026.
Let's see them.
Because honestly, the client list seems almost schizophrenic until you understand that flexibility we just talked about.
Right.
On May 27th, 2026, the Royal Thai Navy ordered 2 C295s configured for maritime surveillance and search and rescue. But then, just 5 days prior to that, the Royal Thai Air Force ordered 2 tactical transport variants.
And don't forget, Spain finalized an order for 18 of these aircraft back in December 2025.
Right. We also have a brief from April 2026 noting it is Latin America's leading tactical multi-mission aircraft, and the documentation explicitly lists its non-military applications too.
Like what?
Things like marine pollution control and disaster relief operations. In October 2025, Ireland began utilizing the C295 as their, quote, eyes in the skies to prevent illegal fishing in their waters.
Interesting.
Yeah. And the materials neutrally report its active deployment in monitoring illegal immigration routes, tracking drug smuggling vessels, pursuing piracy, and even surveying deforestation.
It's everywhere.
It really is. So what does this all mean for you, the listener, trying to make sense of all these international aerospace orders?
Well, if we look closely at how Thailand, Spain, and Ireland are utilizing this single airframe, we see the broader geopolitical pattern I hinted at earlier in the deep dive.
Okay, what's the pattern?
The very definition of national defense is expanding.
Expanding away from just like kinetic warfare, troops and tanks.
Exactly. Decades ago, defense spending was strictly viewed through the lens of combat.
Right,
You bought weapons to fight opposing militaries.
right.
But modern security is far more complex. It requires robust climate response mechanisms, the protection of natural resources like fisheries, immediate disaster relief capabilities, and advanced border surveillance.
Ah,
So when a country invests in a C-295, they're purchasing a military troop transport, certainly.
Yeah.
But they are simultaneously purchasing an airborne command center for hurricane recovery and an environmental asset to track illegal logging.
that is fascinating. The aircraft itself is basically the physical manifestation of this new reality.
It really is.
As a nation's threats become more varied, their tools can no longer afford to be single purpose. I mean, a supersonic stealth fighter is completely useless when you need to drop life rafts to a sinking commercial fishing boat.
Yep.
And a heavy strategic bomber cannot land on a muddy dirt road to deliver water purification systems after an earthquake.
The C-295 thrives precisely because the 21st century is messy.
Right.
It doesn't specialize in one glamorous, highly visible task. It specializes in operational utility,
Yeah.
just adapting to whatever the crisis of the day demands.
That is a fascinating lens to view this through. We started this deep dive looking at a twin turboprop aircraft that, honestly, on paper, doesn't sound like the future of aerospace.
No, it doesn't.
But by digging into the mechanics, the shock-absorbing tandem landing gear for mud runways, the aerodynamic winglets allowing for 13-hour flights, and that cognitive relief provided by the Fitz modular architecture, we really see how this machine serves as a vital tool for a very unpredictable world.
It really does.
It truly earns its reputation as an uncompromising generalist.
And as we wrap up this analysis, I want to leave you, our listener, with a lingering question to ponder on your own.
Ooh, right.
We are facing a century defined by complex, overlapping, and highly unpredictable challenges. From unprecedented weather phenomena to rapidly shifting geopolitical conflicts. Moving forward, will true technological success be defined by creating hyper-specialized, single-use innovations that perform one narrow task perfectly? Or will the future belong entirely to the ultimate generalists?
Wow.
Those highly adaptable workhorses that can physically and digitally reinvent themselves mid-mission to meet whatever reality throws at them next.
That is a brilliant question to leave us with. Well, thank you for joining us on this deep dive into the Airbus C295 and the changing face of global operations. As always, keep questioning the world around you. We'll catch you next time.